In last lecture, we have studied the different types of staircase as well as the basic of the staircase. Now in today's lecture, we are going to design the sums based upon the staircase. So, shall we start? Is my screen visible to everyone?
Yes, ma'am.
Okay. Okay. So we are going to start the problems based upon the staircase. So first of all, design a staircase for floor to floor height of 3.6 meter. Room size is 3 meter by 5 meter. Live load is 3 kilonewton per meter square. And the grade of the concrete and the steel is given to you, that is M20 and Fe415. So as we had studied, there are 4 types of the staircase, that is the straight stair, dogleg stair, as well as open navel stair and the geometric stair. So this particular problem is based upon the straight staircase. So as you can see over here, they have given you the floor to floor height, that is 3.6 meter, and the room size is given to you 3 meter by 5 meter, and the live load is given to you 3 kilonewton per meter square, and the grade of the concrete is being given to you, concrete and the steel is being given to you. So write down the question and draw this diagram. Then we shall proceed with the solution. Who is this user? Rename yourself with your proper name. After completing question and the diagram, let me know so that we can proceed further. For DDRCS, you need to refer IS 456-2000. That is the code for RCC design. It's okay if now you are not having the IS code. From next lecture onwards, keep the IS code with you. You can download the IS code and keep it with you so that you can refer the values from there. Okay, had you completed the question? Yes, all of you are done with the question.
Wait, ma'am, wait.
Okay. As you can see in this particular diagram, this is nothing but the layout of the staircase. So your staircase is of the room size is of 3 meter by 5 meter. So 3 meter width and this 5 meter is the total height of the staircase. And these 1125 is nothing but the landing or mid landing distance. So these 1125 is landing and mid landing distance, and these 2750, this is nothing but the going distance, that is the net horizontal distance of the staircase. And again, this L effective. How to calculate the effective length? So effective length is being calculated. Your total room size is 3 meter by 5 meter. So when you are converted in mm, so it will be 5000 minus 300 is nothing but the width of tread, that is minus 300 by 2 minus 300 by 2. So L effective you are going to get it as 4700 mm. So draw this layout of the staircase.
मैम में गोइंग और लैंडिंग को अपन फाइंड करेंगे ना, क्वेश्चन में नहीं दिया है ना?
नहीं, क्वेश्चन में नहीं दिया है, वो आगे के स्टेप्स में वी आर गोइंग टू फाइंड आउट।
अरे -300 बाई 2 एक तो थ्रेड की है और दूसरी राइजर की है क्या? दोनों को माइनस करना है,
नो,
राइजर और थ्रेड को।
दोनों भी ट्रेड की है। राइजर की विड्थ 150 है। वी हैव टू जस्ट डिडक्ट द दिस लेंथ ऑफ दिस ट्रेड ओनली।
दो टाइम 300 बाई 2 माइनस 300 बाई 2।
यस यस।
Done, ma'am.
Everybody are done with the layout of the staircase. Should I proceed further? Yes, done.
Done, ma'am.
Okay. So you have to consider the height of the riser. You have to consider the height of the riser as 150 millimeter. You have to assume the height of the riser as 150 millimeter for the residential buildings and 300 millimeter for the public buildings. As they are not mentioned here, whichever building is to be considered, we had considered the residential building. So after considering the residential building, we are going to assume the height of the riser it as 150 mm. Then floor to floor height is given to you in the question, that is 3.6 meter. So floor to floor height is 3.6 meter. Then you need to calculate the total number of risers. Total number of risers, how many number of risers are there in your design? So total number of risers will be equals to the 3600. You need to convert this floor to floor height in mm. So 3600 upon 150, that is the height of the riser. You will get the total number of risers as 24. Total number of risers so mil gaye. But number of risers on each flight. How many risers will be there on each flight? So calculate the number of risers on each flight. Need to divide it by 2. So total number is 24. When you will divide it by 2, you will get the number of risers on each flight. So the number of risers on each flight is 12. Abhi number of risers mil gaye. Now you need to know the number of tread. So number of tread, how many number of tread is there on each flight? So number of riser minus 1. So number of risers are there, total 12 risers are there. So 12 minus 1 is 11. You will get the total number of tread in each flight. Then after getting the number of risers and number of tread, you need to consider the width of tread. So width of tread, you are going to assume it again as 300 mm. So solve up till here, then we shall proceed further. After completing, let me know. So we had considered the width of thread as 300 mm. After that, you need to calculate the space occupied by the thread. मतलब आपको total going distance calculate करना है. So total going distance, how you will calculate? 11. What is 11? 11 is nothing but the total number of thread. Total number of thread आपने calculate किए थे 11 and 0.3 is nothing but the width of thread that you have considered. So you have to convert it in meter. So width of thread you had considered it as 300 mm. So after converting it in meter, you will get 0.3. So total going distance will be number of thread, that is 11 into width of thread. So 11 into 0.3, you will get it as 3.3 meter. After this, you need to calculate the width of landing and mid landing slab. Total landing and mid landing slab ki width you need to calculate. So 5 is nothing but the size of the room. So 5 minus 3.3, that is total going distance, divided by 2. You will get the width of landing and mid landing. So width of landing and mid landing will comes up to be 0.8 meter. But according to the IS code, the width of landing and mid landing slab is generally taken it as minimum 1. It cannot be less than 1. So that, but हमारा तो value 0.8 आया, so it is less than 1. So it is not permissible according to the IS code. So we need to change the width of thread. जो हमने width of thread पहले 300 assume किया था, उसकी जगह we need to change it. So we need to deduct it. So we keep it the width of thread as 250 mm. So हमने width of thread कम कर दिया 250 mm. Then again we need to calculate the total going distance and the width of landing and mid landing. So total going distance, same formula we are going to use, that is the number of thread into width. So 11 into 0.25. तो आपको total going distance मिलेगा 2.75 meter. Then again width of landing and mid landing, that is 5 minus 2.75 divided by 2. तो आपको width of landing and mid landing मिलेगा 1.125 meter. So it is greater than 1. So it is permissible. So you have to consider the width of thread as 250 only here. So solve from here. And if any,
मैम वो 5 माइनस ओ जो है वो फॉर्मूला है क्या 5 माइनस 3
yes, 5 is
अपॉन 2
nothing but the 5 is nothing but the size of your room that is given to you in the question. और 3.3
ओके
की
थैंक यू
आपकी वैल्यू आई है वो. Yes, you have to solve. I have given you the time to solve. You can solve it now. After completing, let me know so that we can proceed further. In DDSS, you are having all the formulas in IS code. But in DDRCS, you will not get the formulas, all the formulas in IS code. So you need to remember the formulas in this subject. Very few formulas are there in your IS code. All the other formulas you need to remember. Okay, done. Everybody had completed. All the others had also done. Should I scroll it down? Okay, what about others? Everybody had also completed.
Yes, ma'am.
Complete up till here, width of landing and mid landing. Then we shall proceed for the step number 2. Okay, should I proceed for the step number 2? Done. Step number 1 is being done. So step number 2, in step number 2, you need to calculate the depth of slab. So for D, so for calculating the D, you are having the formula L effective upon 20 MFT. Now, why we are taken it as 20 MFT? So as we are doing this design for simply supported slab. For simply supported slab, the formula is L effective upon 20 MFT. But if the slab is one end continuous slab, you are having the formula that is L by 24 MFT. You can note it down. For simply supported slab, the formula to calculate D is L effective by 20 MFT. And for one end continuous slab, it is L by 24 MFT.
चंद्र स्लो बोलो ना.
For simply supported slab, for simply supported slab, D will be equals to, that is, D is nothing but the depth of slab. D will be equals to L effective upon 20 MFT. L effective upon 20 MFT. This is for simply supported slab. And for second, for end continuous slab, for end continuous slab, D will be equals to, for one end continuous slab, one end continuous slab, D will be equals to L by 24 MFT. L effective by 24 MFT. L effective by 24 MFT for one end continuous slab. Then third, for both end continuous slab, for both end continuous slab, D will be equals to L effective by 28 MFT. L effective by 28 MFT for both end continuous slab. For both end continuous slab, D will be equals to L by 28 MFT. And the last one, for cantilever slab. For cantilever slab, L will be equals to, D will be equals to, L effective by 10 MFT.
L effective by
10, L effective upon 10 into MFT. Okay, but mostly we are going to design for simply supported slab only. So you have to use this formula only, that is L effective upon 20 MFT. So L effective, the value for L effective is 4700 upon 20 into modification factor for minimum height is 1.3. So the value comes up to be 180.76, and you have to consider the effective cover, that is of 25 mm. So do up till here, then we shall proceed further. Again, you have to assume the modification factor value is from 1 to 1.5. So we had taken it as minimum 1.3. For any of the slabs, you have to assume the value from 1 to 1.5 for MFT. Okay. So effective cover, you have to take it as 25 mm. And after taking the effective cover, you need to calculate the capital D. So capital D will be 180.76 plus effective cover, that will comes up to 205.76 mm. So capital D will be 225 mm and the small d will be capital D minus effective cover. So capital D approximately you are taking 225 mm minus 25, that will comes up to the 200 mm. This is for the depth of slab. Then in third step, you need to calculate all the loads acting on your staircase. So do up till here, then we shall proceed for the step number 3. Okay, done. Should I proceed for the step number 3? So in step number 3, you need to calculate all the loads. That is, step number 3 is calculation for the loads. So as you can see, this is the diagram for the staircase, and this is nothing but the total L effective is nothing but the effective length, and this L2 is nothing but this much length. यहाँ से लेके इतना length is your L2, and this is the total L1, that is the total length of the total risers and treads, and this is your tread, and this is your distance X. So draw this diagram so that you can understand what is L1, what is L2, what is L effective for the staircase.
मैम सेकंड डायग्राम ड्रॉ करना है.
हाँ, yes, second one, this one.
मैम जो एक्स का डिस्टेंस है वो मिडल स्टेप का ही खाली है ना?
हाँ, मतलब हर एक इसका सेम ही रहेगा X, because all are symmetrical stairs only. सबका ट्रेड और राइजर का डिस्टेंस हम एक ही एज्यूम कर रहे हैं, अलग अलग नहीं कर रहे. Okay, done up till here.
यस मैम.
Okay. Then loads on the flight. You need to calculate the load on the flight. For that, first of all, you need to calculate the self weight on the slab. So to calculate the self weight on the west slab, you are having the formula, that is L2 distance. Yes, this distance, यहाँ से लेके this one, this horizontal distance. ऑफ दिस पर्टिकुलर, ये जो आपका इंक्लाइन पोर्शन है, इंक्लाइन पोर्शन से लेके ये स्ट्रेट पोर्शन तक का जो भी ये हॉरिजॉन्टल डिस्टेंस रहेगा, that will be your L2, and these all the vertical distance will be L1, and this total distance will be your L effective. Okay, understood?
मैम एल
हाँ,
इफेक्टिव इज द होल लेंथ या फिर इनर टू इनर है?
inner to inner है.
ओके, थैंक यू.
Now you need to calculate the loads on the flight. So first of all, you need to calculate the self weight of the west slab. So to calculate the self weight of the west slab, you are having the formula that is D into 25 kilonewton per meter square into L1 by L2. So L1 by L2 will be equals to X by T. So see this particular diagram, I have shown this. What is this 250? That is the total width of the tread, and this is your the height of the riser, that is 150 that we had assumed in the step number 1. And you need to calculate this x distance. So apply Pythagoras theorem and calculate the value for x. So after calculating the value of x by using the Pythagoras theorem, L1 by L2, why? Because it is the formula only. In formula only, they have mentioned you the this is total formula, that is D into 25 into L1 by L2. That's why we are going to consider L1 by L2. अभी यहाँ पे this is total the you have to apply Pythagoras theorem in order to calculate the value for x. So after applying the Pythagoras theorem, आपको x की value मिल जाएगी. After getting the value of x, you need to calculate the self weight of the west slab. So D already you had calculated. So D is nothing but the 200. So substitute the value for D over here into 25 into L1 by L2, that is x by T. So x की value you had got, that is 291. When you will convert it in meter, that means 0.291 upon T. T is what? The width of tread, that is 250. Again you have to convert it in meters, so 0.25. So after this, after calculation, you are going to get the self weight of west slab, that is 5.82 kilonewton per meter square. So do up till here. Yes,
थोड़ा सा
D is
ऊपर लो ना.
0.225. Last 2 minutes are there. Those who are not given the attendance, give your attendance in the chat box.
मैम टी कहाँ से मिला मैम, टी की वैल्यू?
T की वैल्यू ऑलरेडी हमने लिया था ना, ट्रेड की वैल्यू, width of trade. Width of trade हमने कितना लिया था? 250 लिया था. So 250 mm we have considered. So you have to convert it in meter, that is 0.25. देखो पहले के स्टेप में हमने width of trade assume किया था 250. Understood?
यस मैम.
When the meeting gets over, rejoin it again for a few minutes. We have to complete this sum by today itself. Okay, everybody had done up till here. We are having less than a minute, so whenever the meeting gets over, rejoin it again. Now the formula to calculate the dead load of steps. So for calculating the dead load for steps, again you are having the formula, that is 1/2 into rise into tread into 24 by T. So 1/2 into again tread, width of tread is 0.25. Then for rise